artificial intelligence will completely transform our world. But what is AI? Why will it affect you? And how can you and your business survive and thrive through the AI revolution? Welcome to AI and You. Here is your host, author, speaker, and futurist, Peter Scott.
Hello, and welcome to episode 182. I thought I would add up how much time we have been on the air and found that we have created over 103 hours of content to date. Of course, it took rather more than that amount of time to produce, especially given the rate at which I generate flubs. But that's a significant chunk of content for learning about AI. And I've been hearing from a lot of people lately who tell me that they've just discovered the show and decided to listen to all of the episodes from the beginning. So let's get into this one. My guest today is Oren Etzioni, Professor Emeritus of Computer Science at the University of Washington, and most notably the founding CEO of the Allen Institute for Artificial Intelligence in Seattle, founded by the late Paul Allen, co-founder of Microsoft. His awards include American Association for Artificial Intelligence Fellow and Seattle's Geek of the Year. Allen Institute for Artificial Intelligence is a bit of a mouthful, so they commonly call it AI2. Oren grew AI2 to a team of over 200 researchers and created singularly important tools at the intersection of AI and science research, such as the Semantic Scholar, a search engine that can understand scientific literature, and Mosaic, a knowledge base formed by extracting scientific knowledge from text. This is hugely important because of just how much the rate of research paper creation now outstrips the ability of researchers to read it. AI could transform the productivity of scientific research by unprecedented measures. So let's get right into the interview. Oren Etzioni, it's a pleasure to welcome you to AI and You.
The pleasure is all mine.
So you have been involved in a number of pivotal things that haven't risen to some of the frenetic levels of public attention as lesser efforts or efforts that have made less contribution. And principally, I'm thinking of the Allen Institute for Artificial Intelligence, founded by the late Paul Allen of Microsoft, has made some significant contributions, and you are the founding CEO of that, I believe. And perhaps you could describe Paul's vision and where you took that.
Sure. I always like to point out that what I call our overnight success, right? The sudden emergence of ChatGPT, DALL-E, and their remarkable capabilities. This overnight success has been decades in the making. And one piece of the story is a piece that I was very closely involved with. In 2013, the late Paul Allen reached out to me, and he wanted to create a nonprofit research institute focusing on AI. He had one in brain science, and at a macro intellectual scale, he was kind of hedging his bets. He said, well, maybe neuroscience will solve some of the most fundamental questions in all of science, right? How does the mind work? Maybe we can figure that out by studying the brain. And he was hedging the bets and saying, well, there's this other methodology that's software-based. Of course, he was no stranger to software and what it can do, being the co-founder of Microsoft. So he tapped me to build an institute that uses the methodology of building and investigating software programs to figure out how do we understand the human mind, how do we understand intelligence. And I should clarify, when I say the human mind, I don't mean that we were studying psychology or what sometimes is called cognitive modeling, right? We were not specifically trying to understand how people's thinking work. And that's the methodology of AI, trying to build some kind of thinking machine.
So you're down at like the wetware level? Neurons, cortical columns, are you trying to model things to that level of fidelity with the human brain?
So the Allen Institute of Brain Science, which we refer to as our big sister institute, sometimes we call it AI1, because it was the first Allen Institute, is very much focused on that and very, very deep in the neural structures in the brain. They have a brain catalog that they released a while ago that they went on to. Our approach has been very much divorced from the brain. So the Allen Institute for AI, or AI2 as we call ourselves, so we're number 2. We're also, some people called us AI squared. I took the derivative, so you don't have to put like a little squared symbol, but little nerdy jokes. But basically, AI2 starts with the question of we see intelligent behavior, or we see a task or a problem that requires intelligence. It might be playing Go, which is actually pretty narrow. It might be understanding a sentence. It might be understanding a visual scene. We can talk about many such problems. And we want to build a computer program that does well at that task or that set of tasks. And at that point, we're not thinking about the brain at all. We are unconstrained. We're very focused on our ability to succeed at the task using any software techniques known to humankind. And over time, certain techniques have emerged as quite powerful. Some are loosely inspired by the brain. They're called neural networks or deep learning, and we can talk about those. Many are completely different. And so it is very different. I would say that AI, artificial intelligence, is as different from human intelligence as a Boeing 747 is from a flying bird.
How would you describe then the core mission of the Allen Institute for Artificial Intelligence? And maybe it would help to think of in terms of if it were successful beyond its wildest dreams, how would the world look?
The core mission, very simply put, is AI for the common good. So there are many uses of AI that bring concern to people's mind, can result in privacy violations. We've seen AI's use by totalitarian regimes. I'm worried about AI's use in creating misinformation. But for us, AI at AI2, AI is also a huge enabler, a huge positive. And so when you ask what is kind of the dream vision, the wild success is if we took AI very much as an enabling technology, not as an ends in itself, and we used it to solve some of humanity's thorniest problems. We have a problem with climate change. We have a problem with pandemics. We have a problem with superbugs. We have so many problems where technology, in carbon sequestration, right, in designing new antibiotics, it's in pandemic vaccines. We have so many problems where if science was better and faster, humanity would be a better place. Well, AI is a huge enabler of that, and various projects at the Institute, I could give you examples, very much focused on how does the kind of AI work that we do accelerate science, accelerate the scientific process so that it's not just an abstract connection, but really the AI that we do leads to positive outcomes for humanity.
Well, let's talk about those. Maybe start with the Semantic Scholar. And I interpret that naively as let's make sense of academic papers, scholarly scientific research, which is published in this probably intentionally dense language, like it was hard to do, it should be hard to read. I mean, these are being published at an accelerating rate. It's impossible for an oncologist to keep up with the papers that are being published in oncology now, for instance. So we need AI help there. What part of that problem does the Semantic Scholar address?
So you hit the nail on the head. You've done your homework, Peter. So Semantic Scholar, it just so happens that yesterday we celebrated the eighth birthday for the Semantic Scholar project. So it's 8 years old, which, by the way, is an interesting side note about projects at the AI2 nonprofit if you contrast it, say, with academia. In academia, often projects are oriented around students, which means that once the students graduate, it's not always easy to continue the project, or at least to have continuity across it. And also some projects, let's say, running over the entirety of the massive corpus of scientific papers requires very strong engineering. And again, it's often unfair to task students, whether they're undergrad or grad students, with the heavy lifting of engineering tasks. The beauty of AI too is it's a research institute, we have some very capable researchers, we have student interns and so on. We also have engineers that have joined from some of the very top companies, Google, Facebook, Amazon, etc., and they very much enjoy long-term projects where they're building scalable tools, etc. So it's a different context, and so it's a luxury for somebody like me to be able to run something continually for 8 years for the common good. To specifically answer your question, okay, so what does it do? First of all, it's free. So anybody who wants to check it out can go to semanticscholar.org and use it for themselves. We pride ourselves on that. It's free now. It's going to be free indefinitely in the future. And we started with very much the statement that you made, Peter, that the number of papers being published each year is in the millions and it's growing. In any particular specialty, people estimate that even the most diligent researcher or student can read maybe 200, 300 at most papers per year. And yet in a discipline like oncology and many other ones, the number of papers published is much more than that. So inevitably, to be on top of the state of the art, to understand what's novel, to build on the work of your colleagues, you have to have an efficient mechanism for search to home in on the papers you want to read, an efficient mechanism for skimming to figure out, okay, what part of this paper should I read, and even efficient mechanisms for summarization. So Semantic Scholar started with various ways to make it efficient to search using AI. I won't go through all the details. There's a lot of features there. We developed a specialized feed that you could teach it your interests. You say, I like this paper, I'm not interested in this paper. And like we have feeds on Twitter and Facebook and Google News and various consumer brands, like we have recommendations for products from Amazon or videos from Netflix, this generates a feed of recent papers that may be of interest to you. So instead of scouring the literature every morning in fast-moving areas, did anything come out that I missed this day, this week? It scours the literature on your behalf and suggests recommendations to you. The recommendations keeps getting better based on how you react to these papers. Do you mark them as uninteresting? Do you file them away in your library? Do you eagerly read them, etc.? So we have a search engine. We have a personalized feed, but we go way beyond that. So the most recent innovation for Semantic Scholar, and then I'll stop, is we've developed something called the semantic reader, because however many papers we get it down to, you still have to read them. And we did a lot of work to make that reading process more efficient, being able to automatically extract figures and tables, being able to put definitions on things, put references in context, but then skimming and summarizing is a huge thing. Often when you're in a paper, it can be helpful to look at summaries so you can home in on that key experimental result that you want to read or that key piece of related work. So this is really quite recent. The semantic reader was launched in the last 12 months or so, and it's receiving really exponential growth in usage.
And I want to find out about how these tools can help with the process of distilling additional knowledge out of existing corpuses. It's long been a sort of a fantasy of mine that scientific papers represent some kind of a conclusion. A study was done. We found that A implies B. We discovered this fact about the universe. And a lot of the job of people advancing our knowledge is to find correlations between different papers, different researchers, where you can do some sort of transitive logic and say, well, this person said A implies B, this person said B implies C, therefore I can say that A implies C, and no one knew that before now. Fine, but that's only limited to the number of papers that they can read and find, and the flaw drops out of that as soon as we start looking at cross-disciplinary studies, but there's no reason that there couldn't be correlations in other disciplines. But AI is not limited by that cap and could find correlations among every paper ever published, theoretically, with enough hand-waving around natural language processing. That seems like maybe a potential gold mine if we figure it out. Is your work with these tools oriented towards that kind of goal in any way?
Very much so. So we refer to what you're talking about as scientific discovery or hypothesis generation, although some of what you said might even be a precursor to that, where it can summarize multiple papers, which would be very handy. So if there's, 50 papers that came out on this topic with new results, do I have to read or skim all 50 or even read summaries of all 50, or can the machine do it on my behalf? I know that you've had science fiction authors on the podcast before. So one of my favorite statements is, I like to draw a clear line between science and science fiction. And sometimes in AI, we get ourselves in trouble by emphasizing the fiction. So let me be very clear. This is a holy grail for us, right? Automated scientific discovery. And actually, just a month or two ago, there was a cover story in the communications of the ACM about the inflection point that we see in science based on the work of a gentleman named Tom Hope. He works out of AI2 Israel, and he's specifically focused on this. And he's shown some useful tools that scientists in various disciplines are actually using. Again, I'll refer listeners to the paper to learn more. So I would say that we're actively working on this. Having said that, here are some of the things that we really struggle with. Even taking multiple papers. So it turns out that taking a single paper and summarizing it well is actually now the GPT type of technologies, the new fancy large language models are really good at that. It turns out that if you take multiple papers, even 5, say, and give them to the system, ask them to summarize, it gets confused. The state-of-the-art struggles with figuring out what came from this paper into that paper. How should I put the pieces together? This is solvable. This is not a 20-year project. It's something we're actively working on. But I'm saying as of today, 2023, we don't have an adequate summarizer of 10 scientific papers. That's something we want to work on. We're very interested then in the further problem, though, of going beyond summarizing the literature to generating hypotheses. In the case of generating scientific hypotheses that a scientist might investigate in a lab, say, it turns out that we're, in some sense, too good at it. We can generate so many hypotheses, and now the question is, which are good hypotheses, which I would define as A, novel, and B, important, right? Because you can generate a novel hypothesis that nobody cares about, right? I'll tell you, I think the product of the following 20-digit numbers is X, and that's never been studied before by humankind. Yeah, but once we figure that out, so what, right? So very much runs the risk of generating so what hypotheses, novel but completely boring ones, or generating hypotheses that are interesting but actually are not novel, right? So to be novel, you have to have an understanding of the literature, a non-trivial understanding of the literature. It's not just that the words are different than the words of some paper, right? Because we can say it in so many different ways. And then even deeper, an understanding of the field that a practitioner has who says, that result probably won't matter to people. On the other hand, this result, CRISPR, this merits a Nobel Prize. So we are actually very early in the development of science-generating AI system, even with Semantic Scholar. So right now, Semantic Scholar is very much my favorite definition of AI, which is AI as augmented intelligence. And the idea is that it's a tool, it's a power tool, but it's a tool to help scientists become more efficient at their job, as opposed to, let's say, a scientific co-pilot or something that's just more powerful and really becomes your equal or even your highly capable assistant in the lab, like a postdoc. We ain't got no postdocs, no automated postdocs. We have plenty of human ones.
Yeah, we could always use some automated ones. Assuming you're familiar with the extended mind hypothesis, that we use artifacts outside of our brains to extend our cognitive capabilities, whether they be a notebook or a smartphone or computer. If a calendar extends or allows us to outsource our memory of events, if an address book allows us to outsource our memory of contacts, and if a calculator allows us to offload the business of arithmetic, what does today's AI represent in terms of the cognitive assistance or extension that it can provide?
Really a wonderful question. And the extended mind hypothesis, right, goes hand in hand with the idea of AI as augmented intelligence, right? Together with the machine, we're going to do great things. I'll get to your question directly in a second, but I want to point out that, of course, at least in certain circles, we see some real ambivalence about AI in many levels. There's AI taking over the world, there's AI's job, but even AI is kind of a cognitive K or something that assists us. I know that Henry Kissinger at some point bemoaned, gosh, with all these technologies, do we really need to think anymore? And I've seen headlines like, is AI making us stupider and such? And the reason I wanted to mention this is I recently learned, and I can track down the reference for you, that I believe it was Socrates who was really bemoaning the creation of pencils and writing. He says, if we take these devices, not his words verbatim, but that's the feel of it. We take these devices and we use them to write down our ideas. What is that going to do to our thinking, the purity of it, the spirit of it? And the written word doesn't capture that. It's basically the tenor of it was pencils and writing, pencils and paper are a disaster to thought. And of course, history went a different way. So I think the same here. I think these are, as you suggested, assistive technologies. And I think that first and foremost, they are so good with text, they assist us with our writing, generating drafts, summarizing. As a writer, I often have to put things below the word limit, right? Which is a very painful, right? I've just written something and it's 100 words above the word limit. So I have to shrink it. And the technology is just fantastic. It's absolutely ruthless in shrinking things. You always have to be careful, right? I always like to point out that technology, whenever it changes your text, it can hallucinate some stuff. It can remove some stuff that you care about. So I use it all the time to shrink text down, but I also check carefully that it didn't remove essential components. But again, if I made a mistake or changed the tone in some way, I can then just tell it, okay, fix it in this way. We can have a little dialogue. And I found that it's an extremely efficient aid in my writing. The same with my reading. So again, I'll often get some document, let's say the Biden administration's executive order on AI, which came out recently, and it's, I don't know, about 100 pages long, certainly more than 70 pages and stuff. And who has time to read every word, right? So we turn to AI to summarize. So with the text, it's very helpful, but it's very much not just restricted to text. So now it has capabilities where it can help generate software code. So if we want to write some graphing things or do simple experiments using software, it can help there. It can do data analyses on our behalf. So while I said it's not a postdoc, it is available 24/7, which is an advantage. And certain elementary things it can do are becoming indispensable to me because I don't want to ask somebody else to do them. I don't want to do them myself. It'll take longer and it'll do them quite well. The last thing I want to point out is, and there are a lot of examples of this in the internet with medical diagnosis where you miss something. And you say, I took my dog to the vet and the doctor ran a bunch of tests, couldn't figure out what's going on. I typed the symptoms into GPT, whatever, and it said, what about this? And my point here isn't the doctors are bad or the GPT is the god of medicine. My point is that technology naturally finds things you may have overlooked. So another thing that I love to ask the technology is, what have I overlooked? What's a potential counter-argument to this? Is there a fact that I should remember to include here? All these kinds of questions that if you had an omnipresent, very well-read, not perfectly intelligent assistant could help double check things for you and so on. So I use it in all these ways. And that's for me personally, but whether I'm an attorney, whether I'm a doctor, a veterinarian, or anybody, any knowledge worker, right? It can help me in many of these things. And then the last point I want to make, because you're asking again, how is it helping us? The things that I'm weakest at is actually where it's the most helpful. So for example, I have essentially zero artistic abilities. I'm not musical. I can't draw to save my life. But all of a sudden with these technologies, I can generate amazing pictures, ones I never dreamed that I could, and I can change them at the blink of an eye. So I am also just exploring all kinds of things that I'd written off as, I can't do that. I'm working on an illustrated children's book. The text of the book, which is those 50 lines, that's stories I told my kids a long time ago. I already got those 50 lines. But getting the illustrations right is something I could never do up until now.
That's the end of the first half of the interview. We'll get to the rest next week. The Extended Mind thesis, by the way, is from philosophers Andy Clark and David Chalmers in 1998, and posits that we can consider objects outside our bodies that participate in our cognitive processes to be part of our minds. What does that mean? Well, at the time, their example was a notebook. If you took notes in it and referred to those when you were coming up with answers or thinking about something, then they said, think of that as being part of your mind. Now the more obvious example is a smartphone. It helps you think. It relieves you from remembering phone numbers. It can run Google searches and obviously far more. We form a symbiotic partnership with these devices. Another example is that I interface with my computer via a keyboard, and I've gotten so used to that over the decades that I can type blind without looking at the keyboard or even with my eyes open. It's not just something that I use, but my brain has adapted itself to the machine and created an interface that works both ways. The keyboard is like an extension of my body. Pianists, you know what I'm talking about. AI, particularly the large language models, promises to extend our minds much, much more. In today's news, ripped from the headlines about AI, a team of scientists from institutions like Imperial College have launched a project with the goal of decoding and communicating with sperm whales, who sing in sounds called coders. It's called Project SETI, for Cetacean Translation Initiative. By the way, if you're flashing on Star Trek 4 here, yep, that's where I am too. And the researchers plan on leveraging natural language processing. But first, they need a lot of data. Specifically, they want 4 billion sperm whale coders, but the current database has only 100,000. And of course, if they are successful in figuring out what the whales are saying, the next step will be to speak back to them. What do you think whales are talking about? And what would you say to them? Next week, we'll conclude the interview with Oren Etzioni, when we'll talk about AI2's scientific assistance project called Aristo, Oren's views on the concerns about AI and how to address them, and his Hippocratic Oath for AI practitioners. That's next week on AI and You. Until then, remember, no matter how much computers learn how to do, it's how we come together as humans that matters.
That's all for this episode of AI and You. Please leave a rating and comment and share with your friends. Get the book Artificial Intelligence and You and see more videos and articles at aiandyou.net. That's aiandyou.net, where you can also send us your questions. Thank you for listening.